Kira.
Hi, Kira.
Hey, Kira. All right. All right. That's enough. Okay. So, section 5.5 is algebra of logs at its finest, okay? The things to remember for properties of logs is that multiply. I'm going to be delayed. Sorry. Multiply means add. Multiply means add, and divide means subtract. Okay, I'll do an example of these. Be quiet. Multiply means add, divide means subtract. Okay, when you have x squared times x to the third power, that is multiplying. But what do you do to the exponents? You add them. You are adding the exponents, okay? All right, and let me show you what this looks like in log world. In log world, this would be like log base 10 of 2 plus log base 10 of 4. Log base 10 of 2 plus log base 10 of 4, and I'm going to combine those into one log, okay? It's still going to be log base 10. No, now we're going to multiply. To put them together, we're going to multiply.
So they're like,
Kind of. Yeah, they are inverses of each other because exponentials and logs are inverses of each other. What number goes in the blank? What number goes in the parentheses? 8. 2 and 8, or 2 and 4 make 8. There you go. So, when you're adding two logs together, you can combine them into one log by multiplying. Yes, we're going to talk about that. Okay. So, divide means subtract. So, x to the third divided by x. Divide means subtract. So, let's say I have log base 10 of 4 minus log base 10 of 2. And I combine those. That is log base 10 of 4 divided by 2, or...
That was a bad choice.
I know, I should have done that differently, but anyway. So log base 10 of 2. Right? You take and divide them when you're combining them into one log, yeah? I should have done like 6 and 2 equals 3, but whatever. 4 and 2 is not a very good example, because 4 minus 2 is 2, and 4 divided by 2 is 2. Whatever. There's the rule. Multiply means add, divide means subtract. Awesome. Okay.
Hey, what's the x on the x to the third next to the...
Second is x to the first.
Okay.
Yep. Okay, good. Okay. All right, let's do this one. Use basic properties of logs. So you know multiply, add. I don't know that we're necessarily going to use that for this one, but let's see, okay? You also know some other rules, all right? Multiply, add. Use the properties of logs. Listen. Use properties of logs to solve ln x plus 1. I don't like ln. Change him to log base e. We're going to change him. Log base e of x plus 1 equals 2. Okay? All right. Now, you help me figure out what are we going to do now. We're going to try to solve for x, but x is trapped inside this parentheses. Yeah, exactly. Okay? So Win says let's change him to an exponential function. EXP, exponential function. Okay? First number stays in the same spot. E to the second power equals x plus 1. E to the second power equals x plus 1. Yep, and you subtract 1. That's it. X is going to be equal to e squared minus 1. And you can type that into your calculator and get a decimal. Tell me what you get. 6.389. There you go. Okay? So those are properties of logs. Always change ln when you're solving to log base e. Always. Then we switch them to an exponential function. Good? Okay? So this guy right here is this is the rule. Multiply means add. This is the multiply means add rule, which I've already illustrated up above there. So that's the product law of logarithms. Okay, so example 2, we're going to use that and we're going to figure out what this looks like. So they tell me, you can type this into your calculator if you want to, but they tell me that log of 3 is that decimal and log of 11 is that decimal. This is given. Those are given, and we're trying to solve log of 33 without typing it into our calculator. So basically, we're looking at how can I use 3 and 11 to get 33. Okay? So I'm going to write it like this. Log of 33 is equal to, I write out all my steps. You can skip steps later. But log of 33 is equal to log of 3 times 11. Okay, but then I want to separate those into 2 logs. Right? So this would be log of 3, and then what? Plus log 11. Right? Because multiply means add. So now we are separating. We're going the opposite direction. We're separating. Okay? But log of 3, they tell me, is 0.4771. And log of 11 is 1.0414. Can I add those 2 numbers together? You betcha. What do you get? 1.52. Give me more.
1.5.
185? Okay, there we go. That's it. Okay, so they are just having you illustrate that you know that multiplying is add. Okay, same thing for this next one. They give you this. They give you ln7, they give you ln9. Okay, and we want to do ln63. So I'm going to write out all my steps again. ln63. How can we write ln63? Now, this one, since it's already written in ln, since like my answer, like ln7, ln9 is written as ln, this one I'm not going to change to log AC.
Yes.
Nope, I don't need to. Okay? I'm just going to rewrite 63 in terms of 7 and 9. 7 times 9. Okay? And then that can be written as
ln7 plus
ln7 plus ln9. Okay? So this guy is, I'm just going to plot my numbers in. And you're going to add now. Multiply means add. Some of you guys can do this in your head after you think about like what the steps mean. What? 3, 4?
1, 4, 3, 1.
There you go. There he is. That's it. Okay? We are on a roll. We are on a roll. Okay? Next one. Divide means subtract.
You're recording this for Kira.
I'm recording this for Kira. Yep.
So,
What?
nothing. No, but somebody was making about switch back to Kira.
Oh. Oh.
I think it was.
They said we're going faster because you're gone, Kira, because you're like evidently the anchor in this class or something. I don't know. Right. Yeah, I know. If there was like 2 or 3 people gone in here, it'd be like, whoop, let's go.
What 2 or 3?
I'm not going to tell you.
Yeah.
You can figure it out on your own.
I want to hear you say it.
All right, here we go. Dividing. Dividing means subtract. Okay. So we need log 4. Okay, log 4, but we need to write him in terms of 21 or 28 and 7.
Log of 28 over 7.
Yep. 4 is log of 28 over 7. These are not hard to figure out. Okay, they get hard on the backside.
I don't know. I don't think I would have figured that one out.
I know. Log 28 minus log 7. Okay, log 28, we plop our numbers in. This number goes there, this number goes there. You subtract them, what'd you get?
0.6021.
0.6021. Okay. Good, good.
It's not that bad.
Okay.
What is that on top of?
It's only written. I studied for
Can I make this one harder?
No.
No.
Wait till we get to
I'm hard done.
No?
No.
No. We want to make, okay, we'll wait. We won't make this one harder yet. Okay. ln 18, ln 6. We want to write ln 3. How do we write 3 in terms of 18 and 6?
Divide.
Divide.
Cookie.
18 over 3 is, no wait, 18 over 6 is 3. Blah. ln 18 minus ln 6. What do you get? 1.0986. Okay, 1.0986. There we go. Good, good? Yes, yes.
Alright.
Beautiful. Backside.
Water.
All right.
Water. You know, saying water, for the most part.
Okay.
Oh,
Now, last, listen. This is the last property, I think, on this sheet. Last property. This example 42 on your last homework. We had an example like this. I told you log of x to the third power is the same thing as 3 log x. Okay, I'm going to show you why that works. Okay. This is the one from yesterday. 42 on your homework from yesterday. You had to show why these two are equal to each other. I'm going to show you why here in a second. Okay. So write this at the top of your paper. 10 or log of 10 to the third power. Log of 10 to the third power. Here's what this means. Log of 10 to the third power is equal to 10 times 10 times 10, right? Okay, that's what 10 to the third power means. Be quiet. 10 times 10 times 10 is 10 to the third power. Yeah? Okay, but multiply means add. So really, if I separate these out, this is log 10 plus log 10 plus log 10. And how many log 10s do I have?
10 cancels out.
No. Well, it does, but pretend that it doesn't. Pretend that it doesn't. This is 3 log 10s. Therefore, we know that we can go straight from here to here. Okay, that illustrates you. You lost it? Okay. No, not the 10 power. 10 is down below. Okay. My arrow. This is an arrow.
Bingo.
Okay. There he is.
Walk out.
All right. So these are going to get harder now. These are going to get just a little bit harder. Okay. They give us this, and they want us to find log of the square root of 6. Log square root of 6. They give us that information. Log square root of 6. So we only know what log of 6 is, but we need square root of 6.
So log 6 to the 1/2.
Okay, so this guy is log 6 to the 1/2 power, if I rewrite him, right? Okay. Log 6 to the 1/2 power.
You can't do it, so you move to the front.
Yes, we can't do log 6 to the 1/2 power or whatever.
You can do
So the 1/2 can come down in
whatever
front. This guy comes down in front.
So 1/2 is log smaller.
Wait, you can't just move it down?
You can just, if there is a log there, you can always just move it down. That is handy. Right? 1/2 log 6. So, log 6, we're going to plug in 0.7782. And what do I do with 0.7782 and 1/2? Multiply 1/2 times 0.7782, which is really like 0.7782 divided by 2, right? Those would mean the same thing. Okay, so equals
3891.
3891. There we go. Okay, same thing here. We have ln of 50, and we want to know ln of the cubic root of 50. ln cubic root 50. How are you going to rewrite him? ln 50 to the 1/3 power. Some of these you can do in your head. Shh, you got to be quiet.
Move it down in front.
Move it down in front.
It already gives you ln, so it's 1.304.
Okay, plug him in for 3.9120. Take that times 1/3. 1.304. 0. Well, I don't need 0 at the end, but I just kept it 4 decimal places. So. Okay, good. Easy. Awesome.
Simplifying a spreadsheet.
Yeah, basically. Okay. All right. These ones are going to be really super hard. These ones are going to be a lot harder. Okay. A lot harder. Example 5. Well, kind of. I don't know. Maybe they aren't. All right. They want to write. Listen. These are the hardest ones. These are the hardest ones. Listen. I want to write this as a single log. How many pieces are there in the first one?
3.
How many?
There's 3.
1, 2, 3. Okay. LNs of stuff. All right. And I want to write write them as a single ln. Okay, as a single ln of a whole bunch of junk, right? Okay. All right, so here's the deal. Add means multiply, right? So I'm going to multiply these two pieces together, except that 4 is in the way. Okay, I'm going to move the 4 up and pretend that he's not there anymore. So this 4 is going to go up here. Okay? Add means multiply. All right, so I have 3x and I have x to the 4th power now, and I'm going to multiply those together. I'll write out all my work so Kira doesn't get confused, or anybody looking at your notes doesn't get confused. So 3x times x to the 4th, we're going to simplify that here in just a second, but I'm going to write out all my work, all my steps, okay? Multiply. Add means multiply, but subtract means I'm going to divide, so I'm going to put him on the bottom. What? 3xy. Okay?
Looks good to me.
Oh, wait, that's a good thing that I didn't multiply them together. Yeah. So simplify. Just x to the 4th over y. We can cancel out the 3 and the x, so just x to the 4th over y is my simplified form. There he is. That's it. Okay? So, the thing that you want to do first, before you do add means multiply, subtract means divide, move your exponents back. Does that make sense? So if you have a 4 in front, move the 4 to the back. Do that first, and then do the whole add means multiply, subtract means divide, yeah? Okay? All right. Now they want us to simplify this, so now they're going to have us do the opposite. They're going to have us break it apart, and a lot of stuff is going to cancel out, okay? A lot of stuff's going to cancel out. So this guy right here, let's just focus on him right now. We have a division. We have division. So this is ln of the square root of x minus ln of x. You see that? ln of the square root of x minus ln of x, because divide means subtract, yeah? Good? Okay. But then there's one other thing that we can do, or a couple more things, actually. What's the square root of x mean as a power?
1/2.
Okay, so I'm going to get rid of the square root, and I'm going to call him 1/2. But then, the 1/2 goes to the front, right? So this is 1/2 ln x minus ln x. And we can combine those. We will here in just a second, right? 1/2 minus, what number's out in front of this ln? 1. So this would be like 1/2 minus 1, right? Okay. All right, we're going to do that here in a second, but let's simplify this guy first. Okay? So the second piece, let's do him. So we've got plus. Okay, what are you going to do first for that guy? Move the 1/4 to the front. Okay, so this is like to the 1/4 power, and we're going to move him to the front. So we've got 1/4 ln of ex squared.
Well, the e and the x will cancel out, right?
No.
No?
Okay.
Just the ln and the e will cancel out, but not yet. Let's separate them first.
1/4.
Let's separate them first.
Right.
Okay, so just wait a second. So the 1/4 is there. Ln of e and x squared. I want to separate these two out. So 1/4 is going to stay. I'm going to do brackets here for when I separate him. E and x squared. Multiply means add. So he's going to separate into ln e plus ln x squared. Do you see that? See how that works?
Now you can move it back.
Multiply means add. We're separating them out. Okay. Now the 1/4. The reason why I put this in brackets is because the 1/4 goes for both pieces, right? Okay. Are you a little confused? Okay. So let's backtrack this a little bit. We took the 4th root, made him 1/4, moved him down in front. Okay. Now we want to separate the e and the x squared. And to do that, multiply means add. So I'm going to separate them into addition of between the two. But the reason why I put the 1/4 all the way out in front and put brackets around this is because 1/4 goes with ln e and 1/4 goes with ln x squared. Does that make sense? So when I write him down below, well, just wait a second. One more thing we can do, ln x squared.
Make it ln 2/4.
Okay, 2 is going to come in front. You see that? Okay.
Well, 2 is 25.
I could have done it. They did something. Okay. All right, so now let's distribute the 1/4 through. Okay, so this is 1/4 ln e and 1/4 times 2. What's that make? 1/4 times 2.
Oh, 1.
1/4 times 2, or 2/4 or 1/2, right? I'll write them as 2/4 ln x. Okay, so we distribute the 1/4 through. This one's harder. Okay, distribute the 1/4 through, but the things are going to cancel so nice. So nice.
All of the ln x is canceled.
Okay, so here we go. This guy is 1/2, right? So we've got 1/2
Plus 1/2.
plus 1/2
Minus a whole.
minus 1.
0.
Do you guys see that? 1/2 plus 1/2 is 1, minus 1 is goes away. So those are all gone. You see that? Those are my coefficients out in front, okay? So I have 1/4 ln e, but Cody said earlier ln and e cancel out. Okay, now when they cancel out, what do they really make? They make 1. It's like when you cancel like 3/3, they cancel, it makes 1, right? Okay, so this is 1/4 times 1, which is just 1/4, and that is my entire answer. So that whole thing right there simplifies to 1/4, and that's it.
That is stupid.
That is crazy that all cancels out, okay?
Wait, there's possibility that.
Okay, so be careful with those, because those, there's a lot of work to them. All right? All right, do all your steps out. All right? What? Let's skip example 6. Sure, why not? Okay? Homework 7 is posted on the board. You have lots of time. Get started on this.
Can I go to the restroom?
Yes.
Wait, hold on.